Hey class, for lesson 3, we're going to review applications of systems. So you solve systems of equations in Algebra 1 using substitution, elimination, or you also solve them by graphing. So systems of equations are when you have basically one or more equation, or two variables and two unknowns, three variables and three unknowns. There's three types of solutions when you're solving a system of equations. You either have one solution, which means like you get an XY value, that's your answer. You can have no solution or many solutions. So this might look familiar from Algebra 1. We learned how to solve this type of problem using elimination, where, so like the x and y's line up, and since the x and y, the y's, are -6 and 6, when you add these two equations together, 5x plus 3x is 8x, -6x plus 6y is 0, 48 plus -32 is 16, and then dividing by 8, you get x equals 2. Then you can plug that back in, and you'd have, 5 times 2 minus 6y equals -32. So 10 minus 6y equals -32. Subtract 10. -6y equals -42. Divide by -6, and you'd get y equals 7. So you'd have one solution, it would be at the point 2, 7. So if you were to graph those two lines, they would intersect at the point 2, 7. They have a solution of 2, 7. So that is one way of solving with elimination. But elimination is tricky when you don't have the opposites, like -6 and +6, lined up nicely, so that when we added these equations together, it was eliminated. Well, if you don't have that, it becomes more steps. But we can solve with what's called an augmented matrix and use matrix operations. And so to make an augmented matrix, first you do have to make sure that the x's and the y's and the constants line up like this. So we have x's, y's, and constants. Then we're going to make a matrix with the coefficients. So we're just going to look at the numbers. So I'd have a 2, a -3, and a 9 would be my first row of my matrix. Then my second row would be a 4, a -6, and a 5. And this is x, y, and then these are the constant numbers. Sometimes you'll see an augmented matrix with a dashed line that shows you like where the equal sign was in the equation. Now I can solve this using my calculator. So if I go into, I'm going to go second quit, go back to my main screen, clear it. Go into matrix. I'm going to go over to edit. I'm going to edit my matrix A. It is now going to be a 2 by 3 matrix, and I'm going to retype over the values that are in there to match the matrix that I have on my screen. Remember to use the negative key and not the minus. Okay, then I'm going to go back to my home screen. Under matrix, if you arrow once to the right, you see these math functions. Number 9 is RREF, and that's called row reduced echelon form. And basically what that function does, it's kind of like a program that's been designed, and it takes the matrix and simplifies it down and gives you the answer. So if you go down and hit number 9, so row reduced echelon form, now it wants you to put the matrix in there. So go back into matrix, select matrix A, and then hit enter. So I put in matrix A. It actually looks like it's giving me a no solution here. So let me just double check that I put the matrix in correctly. 2, -3, 9, 4, -6, 5. Okay, this one's not a great example because it has no solution. So when I have a row of zeros on the bottom that equals 1 down here, it means no solution. Let's try another one. Okay, so first you have to line these up. So I want it to be x, y, and then equals. So in the first one, you're going to have to subtract the x over here so that it's -x plus y equals 6. And then move the 2x over by adding it so that it'll be positive 2x and then plus y equals -3. So then you can set up the matrices. Remember, these have coefficients of 1 if they have no number in front of the variable. So on the top, the coefficients are -1, 1, and then 6. And then the bottom row would be 2, 1, and then -3. So I'm going to go into matrix, go over to edit, and it's a 2 by 3 again, and type in this matrix. All right, second, quit, back to the home screen. Go into matrix, over to math, choose number 9, then go back into matrix, and under names, select matrix A, and then hit enter. Okay, this one has a solution. 1, 0, -3, 0, 1, 3. So if you remember that this row is your x's and this was your y's. So this is your x's and this is your y's. So this says that, and then the equals was right here. So this says that 1x equals -3 and 1y equals 3. So x equals -3 and y equals 3. Or you could write your answer as an ordered pair 3, 3. So we can use that idea to help us solve linear word problems. So we're going to set these up and use our matrices to help us solve them. Katie has 70 coins of nickels and quarters in her piggy bank that total $13.90. How many of each coin does she have? So this is a how much of each type. So let's let x equal the number of nickels that she has. And we'll let y equal the number of quarters that she has. So first, she has a total number of nickels plus quarters. She has 70. So we have a total equation. Then we have the total amount of money that she has. Well, a nickel is worth 5 cents, so 0.5 per x. A quarter is worth 25 cents, so it's 0.25 per y. And if we add the amount of money that she has together, it equals $13.90. Now I can set up a matrix using the coefficients. So if this is my row 1 and row 2, row 1 would go 1, 1, and 70 for 1x, 1y, and 70. And then 0.05, 0.25, and 13.90 for row 2. And then this is like the dashed line where my equal sign is. So if I plug that back into matrix, go over to edit, matrix A, be 1, 1, 70. And then 0.05, 0.25, and 13.9. Okay. Go back to the home screen. We'd have matrix, math, number 9, and then matrix, enter for A. And I would get the augmented solved matrix. So it's like having the equal sign here. This was my x column, this was my y column. So that means that 1x equals 18, and then 1y equals 52. So that means that I had 18 nickels and 52 quarters. So for the sake of time, I'm probably not going to solve all of these with the calculator, but I'm going to set them up anyway and get it ready to go. So this is comparing two things. So here you have a choice of two different internet service companies. Cable one is $12 per month plus $2 per hour. Mid-Continent charges $27 per month plus 50 cents per hour. How many hours would you need to use the internet per month before the two services are the same price? So just setting this up first. Cable one charges $12 per month plus $2 an hour. So we'll let X equal the number of hours, and Y is going to be the total cost. So for cable one, Y equals $12 per month plus $2 per hour. So $2 per hour is $2 per every hour that you use it, plus you're paying a flat fee of $12 per month. Now Mid-Continent charges $27 per month plus 50 cents per hour. So 50 cents per hour and then a flat fee of $27. Now this one we really want to use a matrix C to, actually we can still. The matrix C would give us the point where these intersect, which means that it'd be where the X and Y, or where the X and Y are the same. So that would tell us how many hours would be the same. But if you're going to put this into a matrix, you need to line it up. So you would have to move this 2x over to this side by using subtraction. So it'd be negative 2x plus y equals 12. And then moving this one over would be negative 0.5x plus y equals 27. And then you would be able to set up your matrix C. Because the solution to a matrix problem is where, essentially where these lines intersect. You know, this one has a y-intercept of 12 and rising by 2. This one has a y-intercept of 0.5 but rising, of 27, but not rising as fast. And where they intersect is the solution, and that would tell you how many hours, the number of hours that they would be the same at. So finding the solution to the matrix would give you the answers here, where X is the number of hours and Y would be the total cost. Matthew stopped for gasoline twice on a long car trip. The price of gasoline at the first station where he stopped was $2.56 per gallon. At the second station, the price was $2.65 per gallon. If he bought a total of 36.1 gallons and spent $94, how much did he buy at each station? So let's let X be the number of gallons at the first station, and Y is the number of gallons at the second station. So this is a how much of each type problem. In a how much of each type problem, you always have a total amount. So he bought gas at the first plus gas at the second. He bought a total of 36.1 gallons. Then you always have like a cost equation, or, you know, pounds go together. Something else that totals it. In this case, it's money. We have the total amount of money for each one. It was $2.56 per gallon at the first gas station, $2.65 per gallon at the second, and altogether he spent $94. So then we could set up our matrix. Remember that 1x and 1y. So the top row would be 1, 1, 36.1. And this would be 256, 265, and 94. and then you could plug that into the calculator and choose Rref to get your answer. The last one I'm going to do is a distance and rate problem. A plane traveled 540 miles in 6 hours with the headwind. The return trip with the tailwind took 5 hours. Find the speed of the plane and the speed of the wind. Okay, so first, a little bit of a reminder is that distance equals rate times time. So if I know 540 miles in 6 hours, I can figure out the rate by taking the distance and dividing it by the time. Okay? So basically, you have x, you want to solve for the speed of the plane. So let's let x equal the speed of the plane. And y equal the speed of the wind. In this situation, you have two scenarios. You're either going with the wind or against the wind. So you're either going with or against. With the wind, the speed of the plane plus the wind speed is working together. So either those speeds are working together. So the wind speed is adding to the speed of the plane. It's like if you were biking with the wind would kind of make you go faster. And then you want that to equal the rate of however fast it took. Then against the wind, now this time the wind speed is slowing it down, the speed of the plane, so it's minus, and that's going to equal the rate. Well, it was traveling 540 miles in 6 hours with the wind. So 540 divided by 6, let's use the calculator, 540 divided by 6, they were going 90 miles per hour. So with the wind then here would be 90. We want them to both be the rates here. And then against the wind, it took 5 hours. So then 540 divided by 5 hours, they were going 108 miles per hour. Oh wait, that should be the other way around. 5 hours was faster, 108 miles per hour, slower, 90 miles per hour, because it's going to take 6 hours to go against the wind. And then with the wind, it was less time. So, no, I had it right the first time. Sorry, it's 10 o'clock. Clearly, it's late. When it's working together, they're going faster. Working against each other, it's going slower. Oofta. Okay, with the wind, faster, against the wind, slower. Then you could set it up. It would be 1, 190, and then 1, negative 1, 108. If you solve that for x and y using the matrix, you will find what the speed of the plane is and then what the speed of the wind is. Clearly, it's time for me to go to bed. Have a good night. I hope you are not watching this video as late as I am